Good morning to all. I am Mohan, Department of Mathematics. Here, the last class, we are discussing the lot of information about the complex integration. Here also, we are dealing with the complex integration, evaluating integral using residues. Evaluating integral using residues. Residues can be used to efficiently evaluate complex integrals, especially those with poles inside the region is of integration. See, the outside of the pole, it will be f of z deals with the single valued function, it will be a 0. Then the region, it will be inside of the pole, then that we have to evaluate that integral using residues. So that singularities and poles, singularities will, it is not well defined, that point where a function is not well defined. Then the another point of it is a isolated singularity, that point occurs as isolated. Then poles, that singularity where the function has an infinite or finite values, that will be purely decide infinite values. That the concept of singularities and poles are crucial. Then the singularities are points where a function is not well defined, where poles as are a specific type of a singularity where the function has an infinite value. Understanding a behavior of a function near its singularities is key to evaluating integrals using the residues theorem. See, the complex integration, the concept of singularities and poles, it is the pole inside the value we have to find with residue, with using the residues, that where a function as a function infinite value. So it will always, it will comes the infinite value. That behavior of the function near its singularities is key to evaluating that the residue theorem. Then the residues at a simple pole. It's a very important thing, that it is a residues at a simple pole. First one, formula. That the simple formula is calculating residues at a simple poles. And then f of x order. See, that is the important thing, that apply correct residue formula, that we need that identify order. So if we identify the order, then only we have to know that the which correct residue formula, because we have to differentiate, that it will come f of a, that f dash of a and f double dash of a up to f power n of a. So that the pole order identifying is very important. Then computations. See, step-by-step procedure to evaluate residues at simple poles. So if it is a simple pole, we have to define with the procedure that evaluating the residues in a simple poles. Residues at higher order poles. See, now to find that residues at higher order poles. In this way, we are discussing regarding that residues at higher order poles. First one is complex pole. That a complex pole, singularities with order greater than 1. See that the greater order, that higher, it will be calculating the residues using derivatives to find residues at the higher order pole. See, in these residues at a higher order poles, first of all, we have to find the residues higher order. So which order we have to find, then only we have to know that which residue theorem we have to use. So that way, it is very important to finding the value. So in this value will be the inside the region that will be taking the residue theorem. So here we are discussing about the simple pole, then residues at higher order, just we intro. So next class we will see that residues at higher order poles. Thank you.